Students, welcome to class 8A. Today we will start with a chapter, that is chapter 3, squares and square roots. Till now you all have studied about how to find out the area of a square. Now what you used to do, you used to just multiply to find out the area of a square. What you used to do, you used to just multiply side into side, square units. Okay. Now suppose the side of a square is A. So what you used to do, you used to find out, if just multiply A into A square units. So what is square? The square of a number is the product of the number by itself. Remember, square of a number is the product of the number by itself. Okay, that is, if I say 7 square means 7 into 7. So what are we finding? That it is the product of the number by itself. 12 square, it is 12 into 12. Again we are finding the product of the same number. Those are called square numbers. Now in this chapter we will study about the square numbers or perfect squares, properties of perfect squares, patterns of square numbers, and so on. Now you can see this table 1 of your book, that is square numbers of perfect squares. Now what do you find? 1 square, the square of 1 is 1 into 1, that is 1, 2 square 4, 3 square 9, 10. In the same way it is given till 10 square, that is 100. So what do we find? That this 1, 2, 3, 4 till 10, it is given in this table, are natural numbers, or these are called the squares of natural numbers, are called perfect squares. So children, we just studied that squares of natural numbers are called square numbers of perfect squares. Another property of squares are that all natural numbers are not perfect squares. Okay. Now let us take an example. Suppose I take an example of let us take it as 12. Okay. Now what do we just find? You all must have been knowing how to find out the prime factorization of 12 or any number. So first of all we take the LCM with all the prime factors, prime numbers. So 2 6 are 12, 2 3s are 6, 3 1. So this 12 can be expressed as 2 into 2 into 3. Now you just pair it. So it is equal to 2 square, and what do you find here? That 3 is remaining unpaired. So it is not a perfect square. Let me give you another example. Now take an example of let it be 16. Okay. So when you take out the prime factors or LCM of 16, you will get it as 2 8s are, 2 4s are, 2 squares are, and 2 1. So 16 can be expressed as 2 into 2 into 2 into 2. When you pair it, what do you get it as? 2 square into 2 square. So we are getting it as a product of pair of equal prime factors. So this is a perfect square, but this is not a perfect square because it cannot be expressed as a product of pair of prime factors. If it would have been 3 square, then this would have been a perfect square. Now let us start with exercise 3.1. The first question is, which of the following natural numbers are perfect squares? Give reasons in support of your answer. So I am solving first question for you. Exercise 3.1. First question, first one. The number is 729. So first of all we will find out the prime factorization of 729. 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 8s are 24, 3 1s are 3, 27, 9, 3, and here 1. So 729 can be expressed as 3 into 3 into 3 into 3 into 3 into 3. When you pair it, you will get it as 3 square into 3 square into 3 square. So what do we find? That this is a pair of equal prime factors. Here equal does not mean that the digit will remain the same. Means the pairing is being done. Nothing, no prime number is being left unpaired. So this is a perfect square. Okay. So if what is give reasons in support of your answer, in this case you will write down, since 729 can be expressed as a pair of equal prime factors, so 729 is a perfect square. So rest of the questions of the question number 1, I'll be sending you one more question in the PDF, but you will be solving the whole part of question number 1. Now, even if it would have been something like that, if one number is left unpaired, then you will write down that particular number is not perfect square because one number is left unpaired. Okay. Now let us start with question number 2. Show that each of the following numbers is a perfect square. Also find the number whose square is the given number. So let us start with first one or second one. I will do 2304. Okay. So first of all we have to find out whether it is a perfect square or not, and if it is a perfect square, it is a square of which number. Okay, let us do that. So I will start with second one, that is 2304. Again what I will do the prime factorization of 2304 and find out whether it is a perfect square or not. So let us find out the prime factorization of 2304. So first we will divide it by 2. 2 5s are 2 7s are 2 6s are 2 2s are 4, 2 8s are 16, 1 4 4, 2 72, 36, 18, 9, 3 and 3. So we can express this 2304 as 2 into 2 into 2 into 2 to 2 into 2, sorry, it is 2 into 3 into 3. So 1 pair, 2, 3, 4 and 3 square. So we can express it as 2 square into 2 square into 2 square into 2 square into 3 square. Or we can also write down this as 2 into 2 into 2 into 2 into 3 whole square. That is equal to 48 square. So you will write down that 2304 is a perfect square of 48. Rest of the questions, children, you will do as homework. Now let us do question number 3. Question number 3 is, find the smallest natural number by which 1008 should be multiplied to make it a perfect square. So what we will do, we will first find out the prime factorization of 1008 and then we will see that with what number it should be multiplied so that it becomes a perfect square. This means that 1008 is not a perfect square. Let us check it and find the answer. So the given number is 1008. So first of all we will find out the prime factorization of 1008. So 2 5s are 0 4, 2 5 2, 1 2 6. Now we will divide by 3. 3 7s are 7 1s are. So we can express this 1008 as 2 into 2 into 2 into 2 into 3 into 3 into 7. So just pair it. When you pair it, what are you finding? That 7 is left unpaired. Or we can write down this as 2 square into 2 square into 3 square into 7. Now what are you finding? That this number is left unpaired. So the question is that find the smallest natural number by which 1008 should be multiplied to make it a perfect square. So if we would have, if we will multiply this number by one more 7, so it will again, so what will happen? It will become a perfect square. So what is the smallest natural number with which this number should be multiplied? It should be multiplied by 7, because 7 is left unpaired. So this is the required answer. The detailed answer, the way which you have to write down is I will be sending you in the PDF. You will just see how to write down the answers, copy it down in your maths copy and do as I have done in the PDF. Okay. Now let us do the next question. Find the smallest natural number by which 5808 should be divided to make it a perfect square. Also, find the number whose square is the resulting number. Okay, let us now find out the prime factorization of 5808. Two twos are 4, 2 nines are 18, 0 4, 2 ones are 2, 2 fours are 8, 2 sevens are 14, 2 threes are 6, 2 sixes are 12, 2 threes are 6, 1 2 1, 11 11s are 11 ones are. So this 5808 can be expressed as 2 into 2 into 2 into 2 into 3 into 11 into 11. Now pair them. Now what are you finding? That this 3 is left unpaired, and we can write down this as 2 square into 2 square into 11 square into 3. I am writing this afterwards because just to show that this number is left unpaired. Now the question is that with what natural number, smallest natural number, this 5808 should be divided to make it a perfect square. Now if I would have removed this 3, and see, if I divide this whole term by 3, if I remove this 3, what will happen? This will become a perfect square. So which is the smallest natural number which has to be removed? So since 3 is left unpaired, so same reason, since 3 is left unpaired, so 5808 should be divided by 3 to make it a perfect square. This is the required answer, first part. Now second part is whose square is the resulting number. So if you divide this whole number by 3, what will be on dividing 5808 by 3, the resulting number is 2 square into 2 square into 11 square, isn't it? Because this 3 will be removed, or we can write down 2 into 2 into 11 square, that is 44 square. So the resulting number will be the square of which number? Answer will be 44. So this will be the resulting number will be the square of 44. Okay. So children, for today this much only. Thank you.